This is a free response question from 2016 again. If I can write 2016. This is their practice free response questions with a calculator. So you'll need a calculator again, or you can use Desmos. Uh, let's read it together here. Particle Q moves along the x-axis. So that means it's going horizontal. So that its velocity is given. So we got a particle Q, and it gives you an equation for the velocity of it. If I want its acceleration at any time, you take the derivative, but it gives you the acceleration right here. The particle is at position x equals 2 when t equals 0. In the interval from 0 to 5, when is the velocity increasing? And give a reason for your answer. So the velocity would be increasing when the acceleration is positive. So when is the velocity increasing? Not the particle increasing, but the velocity. So velocity increasing, put them together, that means the derivative of the velocity. So velocity increasing, that's acceleration. So what we need to do first is we need to take the acceleration and make it equal to 0 and solve for t, because I need to know when it's 0. So I'm going to make it equal to 0 and solve it. So let me do that first on this calculator and show you how that's done. Okay. So first I'm going to solve it. So menu algebra, and I'm going to solve it. Then I'm going to type in 6 over 5 t, and I'm going to go times, because when you have that variable and parentheses, it wants that times, I think. So 6 over 5 t times sine, and inside would be t squared divided by 5. And we're making that equal to 0, but we have a special stipulation for it, because we only want the answer from 0 to 5. Because it's a trig equation, there can be multiple answers here. So we're going to go control equals, we're going to do that vertical line, and we say we only want the answer from 0 to 5. So we're going to go 0, so by typing in the vertical line and from 0 to 5, it will only give me the answer. What happened? Well, maybe it wants some fancy parentheses. So I only want the answer from 0 to 5, or maybe inside. No. So we got that. It says too few arguments. So 6 over 5t times sine t squared over 5 equals 0. And we want the answer from 0 to 5. And what's the common function is missing one or more arguments. I think there's parentheses I should be putting around. Or maybe it goes inside. Oh, I know what I did wrong. I was supposed to go comma t at the end. You want to do that? And say, hey, to solve it, you need to go comma t. Now try it. Oh, there you go. So anyways, there you go. So I didn't put down comma t to tell the calculator to solve for t. But this is very helpful when you have a trig equation and you have a restriction. I only want the answer from 0 to 5. And the answer to 3 decimal places is 3.963. So from 0 to 5, I want to know if the acceleration I want to know where it's increasing. So if I plug in a number here or here, I want to know if it's positive or negative. I think also a graph can help you at this point too. So if I go to the graph, I'm going to erase what I have here. And then I'm going to type in, because it might be helpful just to even have it typed in. So 6 over 5 x, don't use t, times sine x squared over 5, and then graph it. Oops, what did I do wrong? X squared over 5, and then graph. I'm going to change the window from 0 to 5. And then what do I notice from 0 to 5? So first of all, can you see that's going to be 3.963? I already know it because I solved it. But what do you notice on the left? Is it above or below? So I can tell from 0 to here, it's above. And then from 3.963 on to 5, it is below. So the question is, when is the velocity increasing? So the answer is particle Q is increasing in velocity from 3.963 to 5. Why? And then give a reason for your answer. And the reason of it is because the derivative, or the acceleration, is greater than 0. Why is it increasing? Let's try it again. It's increasing from 0 to 3.963. Positive. So it's increasing from 0 to 3.963 because the acceleration is greater than 0 from 0 to 3.963. So from 0 to 3.963, because the acceleration is positive, that means that the velocity is increasing. You're given a reason for it, not just doing a number line with plus and minus. Okay. It says find the position of the particle Q at time equals 3. So this is a starting value problem. What position does the particle start at? 2. So we're going to put down 2 plus, and for time equals 3, we're going to integrate from 0 to 3, and we're going to integrate the velocity. So if I integrate the velocity, that will tell me how much it increased or decreased from 0 to 3. And then I add that to 2 where it started at, and then that will give me the answer. All right. So in our calculator, we would go 2. Oops. Let's go back here again. So I would go 2 plus, and then I would integrate. And I'm integrating from 0 to 3. And then I'm integrating the velocity, which is 1 subtract 3 cosine, parentheses, t squared over 5. I always double check, did I type it in correctly? So 1 subtract 3 cosine, t squared over 5, 0 to 3, and then control enter, and then that tells me the position of the particle. So it's at negative 1.490. All right. Oh, there it is. Turn the page, or the next page. Part C and D, and then we'll be done. All right, a second particle, R, moves along the x-axis so that's positioned at any time. T is given by a differentiable equation, which means it's continuous, where xr at 1 equals 4. and xr at 3 equals 8. So it's giving you the position. So when t equals 1, the position is 4, and at t equals 3, the position is 8, like 2 points. So then explain why there must be a time t between 1 and 3 at which the velocity is 2. So in order to understand that, this is a question. Velocity has to do with the derivative or slope. Now, we can't take the derivative in terms of equation or a calculator, but we can do just basic algebra. So what is the slope from 1 to 3? So if I go and take these 2 points and find the slope, which is 8 minus 4 and 3 minus 1, I get 4 divided by 2, which is equal to 2. So at some point, so this is what's called the mean value theorem. Which is when IROC equals AROC. It states there must be at least one moment between t equals 1 and t equals 3. Oh, I'm going to run out of space here, but I'll just continue it up here. Where the velocity must be equal to 2. So because the AROC is 2 and it's continuous and differentiable, and what are the two things also we need to write down? Is that it's differentiable and continuous. The word differentiable means it's continuous. You could be continuous but not differentiable, but you cannot be differentiable and not continuous. If it's differentiable, it is continuous. So from 1 to 3, is it differentiable and continuous? And really differentiable means it's also continuous? Then there must be at least one moment in time where the average rate of change must equal the instantaneous rate of change. So we know the average rate of change is 2, so there must be a moment in velocity where the IROC, the instantaneous, must also equal it. It might be more than 1. All right, part D. At time t equals 3, the velocity of the particle r, described in part C, is negative 2. So the velocity at 3 is equal to negative 2. Are particles q and r moving towards each other or away from each other at time t equals 3? And then explain your reasoning. So if the velocity at 3 is negative, that means particle r is moving in what direction? Is that how you spell left? I think that's too many t's. I need to know what the position is at 3. And up there it says the position at 3 is 8. So think of a number line. Here's 8, the particle's there, and it's moving in what direction? And that is, which letter do they call that? R. So particle R is at 8, that's what it says up there. And it's moving left from 8. Now, what do we know about the other particle, particle Q? Do we know what its position is at 3? Well, didn't we just answer that one? Let's go back in time. So what's the particle Q at 3? So at 3, where are we at? Negative 1.490. We answered that already. So can you find approximately where that is? So let's just say here is particle Q. at negative 1.490 approximately. And then what's the velocity at 3? Have we found that out? Well, we can find that out if we don't know it. So we need to go back to question part A and that velocity equation. What we need to know is the velocity of Q at negative 1.490. So I need to know the velocity. I need to know what direction it's moving at that time. So if I go back, actually, we already know this. Right? No, I haven't done it yet because I did the acceleration for the last one. So let's just plug it in. So if I want to find the velocity of there in Q, it gives me an equation for velocity. So I'm going to do it. So it's 1 subtract 3 cosine t squared, but we know what t is. So t is negative 490. It needs its own parentheses, so you don't make a mistake with the sign. So negative 3 cosine, and it's negative 1.490 squared over 5. Oh, no. Sorry. We want to put that in. We want to put in the time, not the position of it. So the time is 3. I'm sorry. So 3 squared over 5. And I get 1.682. Now, what does that tell me? Because the velocity is positive, not there. What's the velocity when t equals 3? So at t equals 3, the velocity is positive, which means what direction is it going? So now look at our cute little diagram. Are the particles moving towards each other or away from each other? So let's write this sentence down. Since particle Q is at negative 1.490 and is moving right with a positive velocity, and particle, what's the other one? Particle R is at 8 with a negative velocity, the two particles are moving together. So it's important that your work by itself is part of the reason, but you still need to write it out in your sentence, why that you did the work you did. So since particle Q is at negative 1.490, it is moving right with a positive velocity, and we showed that right there. And particle R is at 8 with a negative velocity. The two particles are moving towards each other together. What's the word they said? Yes, towards, not together. Towards each other. Done. So write as you write your sentence. Don't just show the math, but also write the math that you did and why. It doesn't need to be a very fancy sentence, but that you're explaining the math that you did. All right, you did it. Mr. G Math, over and out. Good job.